Okay, and so all we've done so far is Avery has told us that we distributed the -2 to 5. -2 times 5 is -10. -2 times -x is +2x. And we rewrote everything else. Okay, Avery, take it away. Talk loud,
Alright, so now we would do, now we would combine the like terms inside the parentheses, which is the +1 and the -10.
Okay.
And +1 minus -10 is -9.
Okay.
So then we would just rewrite it and get 6 minus 2x minus 9 in the parentheses equals -19.
Okay. Next step.
Alright, next we would do the 6 minus the -9 and 6 minus 2x, but you can't do that, so you would do the 6 minus -9, and that would get you +15.
Because subtracting a negative is the same as?
Adding positive.
Okay.
Adding a positive.
Right. So we got 15, right?
Yeah.
Okay.
Then it would just be 2x plus 15.
Oh, hold on a second. Don't forget this negative sign. So this negative sign gets distributed.
Oh, that is distributed.
So it's
So
negative.
It's -2x.
There you go. Okay.
Alright. Wait, but wouldn't it be minus 15?
No, because you did.
It would-
So you did it one way. I'm doing it a slightly different way. So 6 minus -9 is +15. Or you could multiply everything by -1, which would be 6 minus 2x plus 9. 6 plus 9 is still 15.
Okay, so then we get -2x plus 15.
Mm-hmm.
And then we would subtract 15 for both sides.
Okay.
And that would give us negative, I think, 34.
Okay.
Alright, so then we have to divide everything by -2 to get x by itself, but it has to be positive, so that's why we do -2.
Okay.
And then, so our final answer is x equals 17.
All right, so for those people who have not had me for 7th grade math yet, this is affectionately referred to as train tracks. Really, it's called solving a linear equation. And that's going to happen next unit in 7th grade. But I expect you to show your work in this manner. So it's really organized. We can see each step, and it's a lot of steps. But that I wanted to start with that. All right, so really today I want to talk about one thing in particular, but before we get there, I do want to talk about Steve and his trip for 500 miles. This is actually a classic IQ test problem. So don't be surprised if you see this on an IQ test. It definitely shows up. All right, so Steve takes a trip 500 miles from one city to another. He travels at 70 miles per hour for the first 400 miles, but then the last 100 miles, there's a combination of road repair and city traffic that slows him to 40 miles per hour. What was his average speed in miles per hour for the entire trip? Express your answer as a decimal, A, B, point, C, rounded to the nearest tenth. All right. Any ideas on how to tackle this beast of a problem? Anyone? Bueller?
I have an idea.
All right. I love ideas. So it may not be right, and that's okay. Let's have an idea.
Okay, so if you're trying to find the average, couldn't you just do so the average, so for 70 miles, so that would be, you could just do 70 times 4, then plus 40, and then divide that by 5.
That would definitely get us an answer. I'm not sure that would be the one that we're wanting, though. But at least it's an idea. At least we're doing something, right? So you learn more from mistakes than you learn from just watching people. So I really appreciate that that try. That was a good try. there is an equation that's really helpful. Has anyone heard of the equation rate times time equals distance?
Yeah.
We have heard that? Okay.
Yeah.
So do we have the rate of his overall trip?
Yes.
We do. I thought that's what we're trying to find.
Oh yeah, right.
Do we know the time right now? Say no.
No.
No, okay, good. All right. Do we know the distance of the overall trip?
Yes.
Yes, okay, so we know the distance. So we know that rate times time has to equal 500. All right, how are we going to figure out how long it took him to get there? So obviously we're trying to figure out his rate. So that means there has to be some way to find out his time. So how can we figure that one out?
For the 70 miles per hour for 400 miles,
Okay.
well, since he's going 70 miles per hour for 400 miles, if you divide 400 by 70, I think that will give how long he was driving at 70 miles per hour.
Yeah, it will. Okay, can someone help us out with that? 400 divided by 70.
I got about 5.71. Yeah, 5.7.
And we want to keep extra decimals right now. So 5.7, what is it, 1?
Yeah, 5.71.
And this is...
5.714285714.
Okay, that's enough, Walter, thank you. So, and that's in hours, right? We don't need hours and minutes, we just need hours. Okay, so what about when he was going 40 miles an hour? Could I have a 7th grader help us with that one? How would we figure out how long it took at 40 miles an hour?
100 divided by 40, which was 2.5.
Okay, so how long did the entire trip take him?
8.21 hours.
And I'm assuming you just added those together, right?
Yeah.
Okay, so is 8.21 a rate or a time?
Time.
It's a time, okay. So we know that rate times 8.21 is equal to 500. All right, so what's my next step?
So if you put 8.21 into the, oh, you already did that, but
Yep.
if you divide 500.21, then you get what the rate is.
Okay, so divide both sides. So this is like the train track problem from before, isn't it? We're doing the opposite to undo the equation. So the rate is equal to,
60.9.
there you go. So to go over this again, we know that rate times time is equal to distance. We know that the distance is 500, but we don't know the rate or the time right now. But we can find the time because we went 400 miles at 70 miles an hour, which will take 5.714 hours. Well, we know that the next 100 miles is at 40 miles an hour, so 100 divided by 40 is 2.5. And so we added the times together, so it took them a total of 8.21 hours to make that 500-mile drive. Well, we plug that into our rate times time equals distance equation for the time. What's the opposite of multiplying r by 8.21? Dividing by 8.21. So we get r, because 8.21 divided by 8.21, that cancels out. What you do to one side, you have to do to the other. So 500 divided by 8.21 is 60.9. So there's our answer. But that's not what I really want to talk about. You know what I really want to talk about today? You guys are so quiet today.
What do you want to talk about?
I want to talk about quadratics. So, we're going to let p equal 2n plus 1, and for n is equal to 10, 20, 30, or 40, which value of n does p squared minus 1 have the most factors? There's a lot going into this problem. So, how many people got this one right?
I did.
Ooh, very good, I did. Caroline, how did you do this?
So first I did I did two, okay, this is really weird because I hear it on your screen too. 2n plus 1, and then I filled n in for each of the 10, 20, 30, and 40. So first I did 2 times 10, which was 20, plus 1, which was 21, so p was 21 for the first one.
Okay.
And then 40 plus 1, which is 41. And then 61 and 81.
Okay, so I'm going to write this down. How many people are lost already?
I did the same thing, but I didn't get it right because I took a guess. So. I ran out of time.
Okay, fair enough.
Mr. Fransky,
Yeah,
I got
welcome.
it wrong because I typed in, I can't remember what number it was exactly, but I think I typed in like 41 instead of 20
All right, it's okay.
because I was being stupid.
Oh, you're not stupid. Okay, so Caroline, could you say it again? So when you plugged in 10 for n, 20 times 10 is, sorry, 2 times 10 is,
20.
okay, so 20 plus 1 is,
21.
okay, so then when n equals 10, p is equal to 21, and then when you plug in 21, what do you get?
21 to the second. Here, wait. Let me do it on my whiteboard.
441.
Okay, very fast at that. 441 then.
441 minus 1 is?
440.
Okay. When n is equal to 20, what did you get?
440.
No. Well, because when n was 10, we got 440.
Oh, I thought you were, yeah. For when n was equal to 20, it was 2 times 20, which was 40. 40 plus 1 is 41.
So when you plugged in 41 for p, what did you get?
41
1,000.
is 1,681 minus 1. So when n is 20, you get 1,680.
This is kind of taking a long time, isn't it?
Yeah.
There might be a faster way. Would you indulge me for a moment? So if p is equal to 2n plus 1, what is another way of saying this p?
2n plus 1.
2n plus 1. Okay, so instead of writing p, what can I write?
2n plus 1.
2n plus 1. All right, so we have 2n plus 1 squared minus 1. Okay, well, if you square anything, what does that mean you're doing?
Multiplying it by itself.
Multiplying by itself. So, oh look, 8th graders, look. 2n plus 1 times 2n plus 1. This looks like a problem that you've had on your algebra sheets, isn't it? All right, okay. So let's multiply it out. So we're going to use rainbows and smiley faces. 7th graders, what we're doing is we're multiplying each of these two terms times everything in the other term. So we actually have 4 multiplication pieces going on right now. What is 2n times 2n?
4n squared.
4n squared. And we know that because 2 times 2 is 4, n times n is n squared. Okay, good. All right. So what is 2n times 1?
2n.
Okay. Now we're on to this one right here. 1 times 2n is?
2n.
2.
1 times 1 is?
1.
We still have this minus 1 over here, right? All right, so let's combine the similar terms. 4n squared. Do we have any other n squareds that we can put it together with?
No.
No, okay. So 4n squared. 2n plus 2n is?
4n.
4n.
1 minus 1 is?
0.
0. Oh, okay.
0.
Okay, so we know that this is the simplified equation, right? And this is actually pretty quick. Is there a number and a letter that goes into these two things?
N.
N and 4. Okay, so we can factor out the greatest common monomial, or sorry, greatest common factor, which happens to be a monomial. So 4n goes into both of these. So this is equal to 4n. What is 4n squared divided by 4n?
N.
N. What is 4n divided by 4n?
1.
Okay. So now, instead of doing everything that Caroline had to do here, all we have to do is plug in n into this equation because it's much shorter. Much, much shorter. All right. So let's do that for 30 and 40. So 30 times 4 is?
120.
So we have 120 times 31. What's 120 times 31?
3,720.
Okay. Let's plug in 40. 40 times 4 is? 40 times 4, anybody?
160.
160.
Times 41 is?
6,560.
Are we done?
No.
No. What are we really being asked to figure out?
How many factors each one of them have?
How many factors each one of them has? Okay. So, does anyone remember how to find out how many factors a number has?
Kind of.
I like kind of. Does anyone remember the first step?
Yeah, don't you just like divide it by the smallest number that goes into it and then keep doing that until you can't be. You just find the prime factorization, right?
That's right. All right. So we're going to divvy this up. Anya, can you find the prime factorization of 440? Walter, find the prime factorization of 1,880. Who else is here? Claire, can you find the prime factorization of 6,560? Lucy, can you find the prime factorization of 3,720? If I didn't call your name, pick one of them, not the 440, please. Pick one that you think no one else will pick, and go ahead and find the prime factorization. Go!
Mr. Frampke's 47 a prime number.
Yep.
Okay. 41 is prime too, right?
Yep. So I'll give you another couple seconds. All right. So what is the prime factorization of 440? Go ahead and shout it out if you happen to know.
Oh, 2 to the third, then 5 and 11.
Okay. So this is how you figure out how many factors there is for a number. You take the exponents. In this case, we take the exponents 3. What's the exponents for 5?
1,
1. How about 11?
1.
1. So you take each one of those exponents and you add 1 to them. So 3 plus 1 is?
4,
1 plus 1 is?
2,
1 plus 1 is?
2,
So 440 has a total of how many factors?
8.
That's right. So that's how we figure out how many factors there are in a number. Okay. How many? What was the prime factorization of 1,681?
2 to the 4th times 3 times 5 times 7.
Okay. All right. So 4 plus 1 is?
5.
How many factors does this have in total?
11.
Well, that's more than 8. Okay. What is the prime factorization of 3,720?
2 to the third times 3 times 5 times 31.
All right. How many factors does this have?
That one has 10.
Well, that's less than 11. All right, what about 6,560? What is the prime factorization of that one?
5 times 5 times 41.
Can you say it again?
3 to the 5th times 5. Oh, 2 to the 5th times 41.
Times 5?
Yeah.
Okay. How many factors does this number have?
10 as well.
That has 10 as well. Which number has the greatest number of factors?
20.
20 does. All right. So,